Today's topic is going to be factoring, and as you can see, we're starting off in simplified form here. This would be a linear binomial. The highest exponent is 1. I've only got 2 terms. Later on, we're going to do a more challenging example, but we want to make sure you know what you're doing first and what the goal is. The goal is to take this series of addition or subtraction and turn it into a multiplication somehow. That's why the word factor, when we're using factors, we're usually talking about multiplication. 2 factors would be like 5 times 2. Those are factors. So when I'm looking at this and I'm saying factor this out, what I'm really saying is what's common about these 2 numbers. And if any of you have played Categories or Boggle or any games like that, you know you don't get points if your answer is common to someone else's answer. So you have to take those out before you can see what you got. So in this particular example, I'm going to do the same thing. I'm going to try to remove the part which is in each of these. So when you think, what can I divide both of these numbers by? It sticks out to me right away that I can divide them both by 5. Now, I always start with my smallest number because you can't take out more than 5 out of these. 5 is the smallest number. I'm going to check and see if I can divide that 5 out first. So here's the idea. If it's common, take it out. Now, I put a division here. I'm taking it out using division because factoring is to multiply. And I know that division undoes multiplication. So I'm going to get a 5 times whatever's remaining after I divide it out. So I divide the 5 out of both terms. That leaves me with an x. I divide the 5 out of this term, and it leaves me with a 3. I now have an answer that's written as a multiplication instead of being written as a straight subtraction. Now, you could always check this. Distributive property will show you this is 5 times x, 5x, this is 5 times negative 3, negative 15. That's what we had originally. So as you can see, these have the same value. The original expression up here and this expression have the same value. I just knew that I wanted to write it as a multiplication. That's why I had to use division in the intermediate just to make it transfer. Now notice, this is not an equation. You can't tell me what x is. None of us know the value of x right now because it's just an expression. We just changed the subtraction into a multiplication. When I come over to an example like this, I see that it's a little harder to pull out what's common because when I look at my smallest coefficient of 9, 9 doesn't divide into 24. So I can't just pick the smallest number and say divide everything by 9. 9 won't come out of this number. So I've got to now look at, okay, what other numbers could I divide this by? I'm going to look here and say 3 is really the only meaningful number that I could divide out. So I look and say, does 3 go into all of these coefficients? And it does. Whew. Now, if that didn't work, you just wouldn't be able to pull out a number. Sometimes you don't have a coefficient that you can yank out of all these. But here I do. I can divide by 3. But notice, in this example, unlike the other example, there's variables in every single place. So I've got to see if there's the same variable in every place. I have an x, but these don't have an x, so that's not common. I can't pull it out if it's not common to every single term. So x is going to stay where it is. Then I look at the z. There's z here, z to the third, z squared, z squared. I do have z in all 3 locations. So that's common to all of the terms. Now I look at the exponents, 3, 2, 2. My smallest exponent is 2. So I could pull z squared out of every single one of those terms. So I go over here, I go over here, and they're coming out. Now you might be thinking, well, z squared's not up here, z cubed is up here. How am I pulling z squared out? Well, remember with exponents, z squared just means it appears as a factor 3 times. So then I could divide that by z squared. Again, I'm not going to use the word cancels out because that turns into 1. But I'm going to cross them out knowing that multiplication by 1 doesn't change anything. 5 times 1 is still 5. So I'm going to show when you do this division, you're losing 2 of the z's. It leaves you with 1. Those of you that like shortcuts, and I like to save time, when you can save time, save it, you can just do 3 minus 2 is 1. And that's the shortcut to not having to spend the time drawing this out. But conceptually, I just wanted to show that. So I divided 3z squared out of everything because it's common. I'm going to make parentheses because I have to turn this into a multiplication. If I don't make parentheses to show what's left over, it's not a multiplication. So anything that's left over from this division is going to have to go in my parentheses. 9 divided by 3 is 3. X, there's nothing to influence that to change, so it stays like it was. Z, I have to subtract my exponents. 18 divided by 3 is 6. I'm just going to keep the positive sign. I have a y, that's not changing. I had 2 up top, z squared. I also had z squared on bottom. So just like my other example, simplifies to 1, all of it simplified to 1, but multiplying by 1 doesn't change anything. If you followed your exponent rules, we have 2 minus 2, which is 0. When you have z to the 0, as you can tell from this picture, that's the same as 1. We don't even have to record z. I'm not even going to put a z there because I see that they simplified out. And then when I move over to my last one, I have 8. Same purpose as before, the z's just simplify out, and I have my answer. Now, not a great looking answer. That's not something that I would like to work with. I'm a math teacher, and even me looking at that go, probably not going to see a ton of these ones. But I have to have the ability to recognize what's common and pull that out. So factoring is a process where you take something that's in simplified form, and you change it into a multiplication problem by pulling out all the common parts. And we pull it out by using division and rewriting what's left over in parentheses. Thank you for watching.